The theme for this week is, what is big data? We use the term a lot, often loosely, but it does have some definite meanings. First off, big data is complex, difficult to collect, difficult to analyze, and often misleading. We tend to think of data as row-by-column collections, for example, spreadsheets. But we may have several rectangular data sets, for example, an Excel workbook. Because of this, data sets tend to be very large. 100 spreadsheets, 100 observations, 100 factors, 1,000,000 data points. For example, let's look at movie rental data. Each day, viewers download, watch, and rate movies. Viewer by movie gives us a rectangle, and then day by day gives us a box of rectangles. Millions of viewers, thousands of movies, thousands of days, trillions of data points. Another example, one we'll look at later, is called Wikilogs. So since 2007, the Wikipedia project has tracked the number of page requests per hour, per page, and that entire set of data is what's known as the Wikilog data. We have pages by hours. We have page requests or hits during the hour. This is our actual data. It's just integers. And we have lots and lots and lots of days. So there's approximately 5 million pages, 24 hours, 2,500 days. That's 3 billion hit counts. Recommender systems is an example we'll look at, where we have books or products that are recommended to users or customers. We'll be looking at a database of about 100 megabytes, but there exist petabyte-size databases. Here's the thing, databases have always tended to be large. In the past, we didn't use large data because we were restricted by the theory and technology. For example, ports have been collecting tide data for centuries. So we have huge amounts of tide data, but it's not really been all that useful until Lord Kelvin built a machine in the late 1800s that would take the tide data and predict low and high tides in different ports. So this was huge amounts of data being put to work one piece at a time. However, huge data is not necessarily what we would call big data. So what do we mean by big data? Well, big data refers to data sets that are both large and complex. Complexity refers to dimensionality. Dimensionality is related to independence. For example, here are geometric features of 1,000,000 squares. This is a large data set, but it's not very complex. The area is the square of the side, the perimeter is 4 times the side, and therefore it's pretty easy to analyze this data. Complexity, on the other hand, is related to dimensionality. And dimensionality of a data set is related to the dependence or independence of its features, which we call factors. The geometric features of squares data has really only one independent variable. We could choose a different factor to be the independent variable, but again, just one. And dealing with one independent variable, not too hard. But what about many independent variables? Well, that means you're going to be working with many independent processes because independent factors represent independent processes. Here's an example. Let's suppose we toss a coin. If we say 1 is heads and 0 is tails, and X is the factor describing this feature of the coin toss, then all we need are these 2 points to characterize the 0, 1. If we had a random number generator, it would generate an entire continuum of points. However, it's still just one-dimensional. Let's suppose now that we actually flipped 2 coins independently. Now we have an x-axis and a y-axis, and because of the independence, even though this is a finite set of values, the best way of thinking about these 4 values is in terms of their XY coordinates. So this is a two-dimensional representation. One coin, one-dimensional. Two coins, two-dimensional. It is just a finite number of points. However, this is the best way to think about it. And that carries over to many dimensions. So if we had one feature, we might call it x1. If we had another feature, x2, a third feature, x3, and that's given us a three-dimensional data set. But what if we have hundreds or thousands or millions of features? Then we just keep adding coordinate axes and keep adding, and we can't visualize it. It's just a big mess. However, this is what we mean by complexity, things that happen in extremely high dimensional settings. Here's an example. Let's suppose that we did a random experiment. Each factor xi will be the outcome of the ith trial of the following. Choose your favorite die, either the 6-sided die or the 8-sided die. Whichever is your favorite, you're going to use twice as often at least as the other. We've assigned 1 through 6 for the 6-sided die, but so the average or expected value of each xi is the same, we pick 0 through 7 for the 8-sided die. Each trial, each random choice of a die and subsequent roll is independent of every other trial. So that means if we have 100 trials, as we do in this set of data, then we have a 100-dimensional problem. Now that means that if we want to ask the question like in observation 2, was the 6-sided or 8-sided our favorite, it's a 100-dimensional problem that we're going to have to look at. In observation 14, what's our favorite? Again, we're working with a 100-dimensional problem here. So this is a contrived example, but in the real world there likewise are many independent processes occurring at the same time. For example, here's some genetic expression data, which is called microarray data, and it's collected from an experiment. This experiment is characterized by the fact that some of the genes were activated by the experiment, class 1, and some were not. But genes can be activated by many, many independent processes, metabolism, respiration, DNA repair. The experiment in question is only one such process. So big data is complex. And the word complex means systems that have a large number of independent variables, high dimensional, lots of interaction among these variables, and those interactions could be chaotic or they could be just ordinary processes. They're all mixed in together. Real world systems tend to be complex systems, and such systems produce complex data. The data sets have to be large in order to capture this complexity. Modern data sets tend to be big data. They tend to come from experiments or observations that are high volume, lots of data, and high variety, lots of different processes. So many processes means many independent variables. Many independent variables means high dimensionality. Big data tends to be complex, at least in the sense that there's high variety across very high dimensional contexts.